This tutorial was inspired by an artwork I've seen in internet some time ago. The original art was made by a randomograph, and if I'm not mistaken, he made it in Houdini. So I decided to try out and recreate it using Blender geometry nodes. And here you can see what I've got as a result. Please notice that I've made this tutorial in Blender 3.0, which now has a totally new geometry node system. And honestly, it is awesome. So if you haven't updated yet, I highly recommend doing this now. But also, if you are watching this tutorial after newer versions of Blender were released, then probably you are able to make the first part of this tutorial in a fully procedural way. As I think in Blender 3.1, they already added a node which allows you to create the Voronoi mesh right inside the node system. Anyways, this method has its own pros and cons, so let's get started. If you'd like to skip the tutorial and just get the complete scene, or if you'd like to support the channel, you can get the Blender file of the scene from the gumroad.com by following the link in the description. Let's delete the standard light and camera and start the work with the cube. Scale down the cube by z-axis to 0.1 and scale up x and y up to 10. Press Ctrl A and apply the scale. We'll be breaking the object using particle system, so keep it seen to have less particles generated by the height. Now create the particles and turn on the X-ray mode so you could see them. In the particle settings, I'll keep all the standard values, and the only thing I need to change is an end time to 1, so all the particles will be generated at once. Now go to a Source tab and change Emit from Face to Volume. This will generate particles inside our cube and not on the surface. To create the Voronoi pattern, you'll need to activate a Self-Fracture add-on. So go to Preferences window and make sure it is active or activated now. Press F3 to open a search bar and start typing Self-Fracture. Right now I will not dive deep into all the settings of the plugin. By now we'll need only a few, like a source limit. If we set it to 0, we'll get the amount equal to the number of particles. And the noise, which will add some extra variety to the shards. Then press OK and wait until the particles calculated. It may take a while. Just don't click anywhere else after the result is calculated, because our pieces are all selected right now. So press M and create a new collection for our fracture. Also, notice that the original geometry is still in the main collection. You can always use it to regenerate pieces if you're not satisfied with the result, but for now I'll just hide it. With all the pieces selected, press Ctrl J to join them into one object. I'm doing it only to simplify the cleanup process. Switch to Edit mode. First of all, we'll need to get a planar surface, preserving only the top polygons. And trying to select it manually won't bring you an accurate result. So we'll be orienting on normals instead. Select any face from the top view, go to Select, select Similar, and choose Normal. Now in the settings, decrease threshold by holding Shift, and decrease it until some faces become deselected. So keep the value as low as possible, right before they become deselected. Now we only need to invert the selection, which is Ctrl I, and delete selected faces. As you can see, the selection worked perfectly, but still it is a good idea to scale everything down by Z-axis. So the polygons that have been deselected in the first place now will be pointing the same direction as others. Next, let's clean up all the vertices that are laying on the same straight edges. To do that, select all the vertices, and in the Delete menu, apply Limited Dissolve. Nice! Now it's time to make the pattern seamless. And it might look a bit time-consuming, but actually the process is very simple. So activate both Face and Vertex mode, then select everything and reselect any vertex from the edge. Change Transform Pivot to Active Element and activate the Snap tool. Now move the plane by X-axis so the border lay at 0 coordinates. Select the opposite side and move it to the left to align the borders. Looks like I've got this extra teeny polygon after our cleanup, so I'll just delete it. Now do the same with up and down borders. The edges are already seamless, so we only need to fix the cross inside. Let me place it in the center. And now we have to merge the vertices inside to rebuild those middle pieces. I mostly use the merge tool to connect the points. This will also connect the neighbor polygons, but we will split them later. Also, you can subdivide some edges to add extra points. Or use a knife tool to add some extra edges. Don't think too much on how you join these pieces, just try to add some variety to the plane. Also, the less pieces you have in the beginning, the faster will be the process. Now, there's one little remark I need to mention here. As you get close to the edges, try not to change the outer vertices. Mistakenly, I did some changes here, so it required some extra steps to fix the seams later. But without touching them, I could get the same good pattern, but without those additional steps. So the pattern is ready. Now I select all the edges and mark them sharp. And have to fix my mistake when I touch the borders. So I select the outer row of pieces from the left and attach them to the right with using a vertex snap tool. Now I only have to find and fix those vertices. I have to repeat the same with the bottom. But as I mentioned before, you could avoid these extra steps if you don't touch the borders in the first place. At last I can separate the polygons. Go to Mesh, Split, Faces by Edges. And once again I'll bring it to a 0 point of coordinates. Okay, I guess I'd like this one polygon to stay on top. So now we have the fractured surface. There are still a few small gaps between our pieces left. I'll quickly fix it before we move forward. I don't merge anything this time, just simply using Snap tool. The plane is ready and it is stylable. To use it in geometry nodes, we'll need those pieces to be separate objects. So go back to an edit mode, select everything and press P to separate by loose parts. Then you'll see how all those pieces became separate objects again. And with all of them selected, go to Object, Set Origin to Geometry. Now each shard has its own pivot point right in the center. And as the base is ready, let's go into geometry nodes. Make sure the scene collection is active and add a plane to the scene. Let's turn off the fracture collection and with the plane selected, create a new geometry node group. Let's also rename the plane to Nodes 3. And now we should add our shards into the nodes by using Collection Info node. Choose the fracture collection from the list, check Separate Children, and switch Transform Space to Relative. To expand the field, create two more nodes, Join Geometry and Set Position. Connect them all together and now by changing the offset, you'll slide a copy to the side. Duplicate the Set Position node and reverse the offset value either to positive or negative. Then copy the whole structure once again. But replace offset by X with the offset by Y. Here you have 9 clones of the field. You can repeat this step as much as you need to add more copies. But for this tutorial, 9 is enough. Next we add a Rotate Instances node. By changing rotation, as you can see, all pieces turning around their center. We're still missing the sphere in the scene. So let's add it. Scale it just a bit and place over the plane. And let's smooth the normals as well. Now we need to add it to our geometry node structure so we could tell our shards if the sphere is near. So create an Object Info node and select the sphere from the list. To compute the location of the sphere, we'll have to use a geometry proximity node. Simply connect the sphere to the target. And if we connect the distance to a rotation node, you'll see how all our pieces rotating based on their distance from the sphere. We'll need to make it relative, but let's set up an angle first. Change the proximity tangent to a point and add a mix RGB node to the scene. Also add the color ramp to the distance output and connect it to the factor. The colors will contain different angles, but now let's take a look on this node using only black and white values. You should see how the rotation has changed in the middle. Let's finally switch the sphere's info node to relative. And now, if I move the sphere, only the nearest shards are rotating. So let's set up the angles. For the base field, create a mass node. Choose 2 radians from the list and set degree to 0. Now let's set up the tracing rotation. Find a line Euler to vector node and connect it to the first color socket. Then set axis to Z and let's set up the input vector. We're gonna get ahead and get a vector mass node, plug the sphere location as a first vector and connect a position node into the second vector. Change the function to subtract, as if you subtract a source position from target position, you'll always get a vector pointing from source to target. I want to visually separate the geometry from the computing part of the nodes, so I will create a frame and place all the nodes responsible for fractured pieces inside those frames. Also, let's label it as a field fracture. Now I'm gonna go back to the mathematical part of the nodes tree and let's finalize the rotation effect. To increase the influence of the sphere, we'll be using map range node. Start increasing from max value and you'll see how the area influenced by the sphere increases. You also might want to play with the different interpolation types. I'll start with a smooth step for this tutorial. Now we'll go ahead and make the shards right under the sphere also flat. To do that, we'll have to edit our color ramp node. So, add an extra color stop right in the beginning of the ramp. And simply tweak the ramp until you like the result. You also might want to increase the Euler factor over the value of 1 by simply typing a bigger number. The higher the sphere will be over the plane, the bigger factor might be needed. It's time to add some thickness to the shards, and there are actually 2 ways on doing this. The first way is to add a realize instance node, so we convert our instances into real geometry, and then simply add a solidify modifier under the geometry nodes. I also add a bevel to soften the edge. But in this solution, you will see that bevel doesn't allow you to bevel those edges far enough. It happens because the modifier treats all the pieces like one geometry, and there are some small shards which have vertices too close to each other. And those shards are preventing the bevel to go any further for all geometry. But as I wanted to see my shards a bit softer, smoother, I used another method. So let's delete both modifiers, and also I'll get rid of instance realize node. Let's activate our fracture collection and hide our nodes tree geometry. Select all the shards in the fracture collection. Make sure you're looking at the active one. And now let's add modifiers to this shard. First I'm adding solidify, and when I press Ctrl L, I can copy it to each of the shards. Actually, let's add a bevel first, and then again Ctrl link to copy the modifier on each selected object. To change any parameters of the modifiers for all selected objects at once, always hold Alt while changing the value. If you don't, you'll be affecting only one active element. So, this way we've got the structure where bevel affects some shards stronger than another. And let me show you. I'll just hide the wireframe and let's shade smooth to see everything better. Now you can see how random the bevel is for different pieces. You always can stick to the first method, but I kinda like this randomness. I will also activate an auto smooth in the object data properties to prevent any shading issues. Let's hide our fracture collection and get back to the nodes once again. As you can see, the effect is already very close to what we have seen on the preview, but I'll show you a few more tweaks that I added to make the effect a bit more interesting. With this have been told, let's add a noise texture to the ramp node. To mix it with the map range, I use a mask node with a divide function. And also I create a mass multiply node to control the strength of the noise. Look how random the pieces can be. You also can use mix RGB node instead of mass node to mix noise with the geometry proximity distance. In this case, you will have a factor input as an extra control of how strong the noise should be. Just choose a divide function from the list and you're set. I also want to draw your attention on how this multiply node works. When the value is high enough, the noise appears all over the field. You have probably noticed on the preview how some shards were jumping outside the influence area. So it happens when the multiply value is higher than 1. If you would like to avoid those jumps, just keep the value a bit lower than 1. Also, let's increase the map range maximum for 14. And let's decrease the factor a little bit. You also can play with the noise scale value. Okay, we're done with the nodes. And now, before we set the animation, let's create a camera and set up the view. Align the camera to view with Ctrl-Alt-Numpad 0. Then press N, and in the View tab, activate Camera to View mode. Then you can easily correct the angle. I'm trying to show as much field as possible. And after you set the view, just don't forget to turn off Camera to View mode. We're finally getting to the animation. Create a circle curve, scale it and move to the center of the view. We'll be using this curve as a path for our spheres, so make sure it isn't too close to the edge of the frame. Then select the sphere and go to the Object Constraint Properties tab. Choose Follow Path Constraint from the list and select the curve as target. To keep the sphere on trail, make sure that all transforms of the sphere are set to 0. Now let's animate the constraint. I'll switch to the Layout tab because I don't want to change my Geometry Nodes workspace. Make sure you are in the first frame and set the key for the offset parameter. Then at the last frame, change offset to 100 and set the key again. You can think of the offset value like a percent of the path that the object has already traveled. So 100 is a full circle for us. And by setting these values, we made a perfect loop. Let me bring the path a little bit higher. Okay. On the reference, you've also seen how the sphere has been slowing down on the poles. To recreate those effects, let's add one extra keyframe right in the middle of the timeline. It's our 50% of the path. And now let's switch to the graph editor. Select all the keyframes and change interpolation to Bezier. Let's turn off the normalization. And now we need to slow down the movement in the middle frame. To do that, simply go to Key menu, Snap, and find Flatten Handles. And if you play the animation, you will see how the sphere made 2 stops while following the circle. But we need it to slow down, not to stop. So, quick tip to fix it. Select all keys, but do not select the handles. Go to Key, add F-curve modifier, and choose Generator. The animation curve immediately became linear again. Let's mix it with our original keys. Press N to open additional settings, go to the Modifiers tab and activate Influence checkbox. Now, if you lower the influence, you'll see how our animation curve gradually mixes linear animation with the previous keyframes. I will keep the influence on 0.3. The animation is ready, and the only thing left to be done is setting up materials and lights. And as it is not a tutorial about materials, I will simply use some prepared materials from the Blender Kit add-on. And in case if by any mystical reasons you have never used it, it is a free pre-installed add-on that you can activate in the preferences. Just type in Blender Kit in the search and activate the add-on. Then you'll have to sign up or log in to start using it. And then a little search bar on top of your 3D viewport will appear. Make sure the second icon is active. It is a Find Materials icon. And then type in any name of the material in the search. You can apply them to your objects by simply clicking on the material. In my example, I used a metal scratched material by Andrei Levintsov. Now let's switch to the shading mode, and as you see, we cannot see the material on the surface, because we need to apply it inside the geometry nodes. Let's switch to geometry nodes workspace and create a set material node. Add it to the node tree and select the material from the list. When I activate the shading mode, the material has appeared. For the sphere, I used some lead material with some glossiness. Then let's move to the shading workspace and tweak the materials a little bit. Here I can change the color and the light intensity. You also can play with the outer rim. Let's switch to the render mode and make sure you are using cycles for rendering. Then let's add some lights to the scene. I start with a fill light. I create an area light for it and then scale it up, like a lot. Also, I move it up and increase the power to 1000 watt. This light gives me a natural edge vignette. You can also change the shape to a disc to get a softer line. I scaled it up to 50 meters. Next, let's add some tinted key light. I use one more area light with a rectangular shape this time. I also increase a vertical size, but keep it narrow. Let's move it to the side and rotate it so it points directly on the sphere. This light should be much brighter. I will set 2000 watts. I also change the color from the white to light blue. Finally, the last light I used was a rim light. Once again, it's an area light, big enough to affect the whole field. I put it underneath the surface and change the color to light blue. Keep it power low, so it gives just a slight volume to the shards from below. Once the lights are set, we can get back to our materials and tweak it once again to finalize the look. I will probably only add some color to the metal material of the field to add some bluish tint. So I create a mix RGB node with a color blending and change the color to light blue. I'll also tweak the color of the sphere a little bit. And that's it! I rendered the scene by splitting it on two different layers, like for a surface and for the sphere. And then, during the compositing, I added those bloom effect to the sphere. And if you'd like to check it out, you can get the original scene from gumroad.com. There you will find all the render settings and compositing nodes. Basically everything that you need to render the preview-like scene, except the final color grading, which you have to add later using any video color correction software, as unfortunately Blender lacks a lot of color grading tools. And that's all for today. Hope you guys liked this video and see you the next time.